As I like to do, I was looking through the CockroachDB release notes of the last couple of releases, and I discovered LTREE, which is short for label tree, and it allows you to represent hierarchical data in a way that not only makes sense to read as a human, but to process as a database. It prevents you from having to write complex hierarchical recursive queries in order to represent hierarchical data. Now, this is really useful because it opens up a bunch of new possibilities within CockroachDB. For example, it's now much easier to store bill of material data, product categorization data, geographic hierarchies of data, and permissions data within CockroachDB tables. And I'll show you how. First, I'll create a demo database with 3 regions: EU Central 1, US East 1, and AP South 1. The reasons for this will become clear in a minute. The first table example I'll show you is permission based. So I'll create a employee table that will have an ID and an email, a resources table, and this will represent files and folders and things like that. I'll create a permission level type, which will store either view, comment, edit, or owner, a permissions table to map a employee with a resource and a permission level, and I'll insert some employees. Next, I'll insert some resources, and this is the L path value. At the top level, I have company. Under that are projects that my company might be working on, separated into those specific projects. So project A with designs, code, back-end code, front-end code. Same for project B, and any HR policies or handbooks should be available to all employees. Next, I'll insert some permissions. The SecOps group, the security team of my company, have owner access at the very top level down. The program manager for my company has owner access to all of the projects. The product manager for project A will have owner permissions for that project and everything underneath it, whereas the developers might only have code access, either back-end, front-end, or everything, and that will be edit access. The designers will have design access, etc. Notice here that there's a special permission, which I'm using as a sentinel value to mean all employees, and that allows me to surface up common things that everyone should have access to. And now with some simple non-hierarchical queries, I can run a bunch of optimized queries to list permissions and to determine whether an employee has access to a given resource. This query returns all of the permissions that this software developer has access to and any common company data they have access to, and whether those paths are inherited or not. So here we can see that they have direct access to the HR policies folder. That's not inherited. They do have inherited access to the handbook because that exists underneath policies. So anything that gets added into the policies directory or subdirectories, they will automatically inherit. And they have edit access to both the back end and front end of the code for project A. Note also that I didn't have to give them specific back end and front end access. These are inherited from the level above. If they're just browsing the company structure, this query will determine whether or not they have access to a given path. For that same user, I'm also checking whether they have access to backend, which we of course know they do. And they do, they have edit access. And if we run the same query again, but this time targeting the project B code, they won't have access to that and I won't get any results. The next demo is on product categorization. Let's suppose you have an e-commerce site that sells products. LPath gives you a concise way to describe the different product types and allows for smart searching across those product types. First, I'll create a product category table, which will store the LTREE path, a product with a path and a price, and then I'll insert some product categories. So electronics, computers as a subcategory of electronics, laptops as a subcategory of computers, etc. Now I can insert the products themselves. So gaming laptops, jumbo cord sofas, and the like. So this is a company that sells loads of stuff. And then I can run some queries. I can return all of the products that are under my electronics path, and that returns laptops, desktops, phones, and everything like that. Or I can perform a more direct search for computers if I'm looking for computers specifically, and that only returns computers. Note that the phones are now absent from that search result. I can narrow it down even further to laptops, and further still to business laptops. And that's all from tweaking this path. And with this query, I'm looking for descendants of this path. So anything that's a descendant of a business type laptop, the reverse would be a parent level. And finally, we'll look at geographic hierarchical data. And I'll tie this into CockroachDB's powerful multi-region capabilities as well. First, I'll create a database called Roast, whose primary region will be in Frankfurt, with additional regions in the States and India. Next, I'll create a table called product location. I'll be selling products again, but this time I'll be categorizing on the location. So I'll have a location, which is my LTREE in this example, the product name, quantity, price per kilogram. This is a coffee example, and I'll be deriving the CRDB region by a subpath of my LTREE. This will all make sense in a minute. This is totally optional, but if your LTREE lends itself nicely to this, it's a good way to drive that CRDB region column. Next, I'll insert my data. For my location, I have 5 levels. Global represents the world, then the high level geographic region, so EMEA, APAC, America, etc. The country code, the area within that country, and the city, the type of coffee being sold, the quantity of that product we have on hand for that location, and the price per kilogram. And because of the case statement in my table definition, I can now run this query and we'll see that the CRDB region, the column that I'm using to determine where data is physically stored, is being driven by the location. So wherever we see EMEA, I'm storing data in Frankfurt, and whenever I'm seeing American data, I'm storing in US East 1. This will be the same for AP South 1 as well. Let's run some hierarchical queries. These would look a lot more complicated without LTREE. First, I'll show you products and product values for one city. I'll extract the city name as the location, the name of the product, the amount that I have on hand, and the total value that I have of that product for Liverpool. And this is calculating all of these values grouped by Liverpool, a subpath element of my LTREE. I can go a level higher and look at one region. So this is the north of the UK at this point, not just Liverpool. And we'll see that we have both Edinburgh and Liverpool now, again grouped by their cities. I can go a level higher to just the UK level this time. And now we're factoring in London, and it carries on like this. I can go a level higher and look at EMEA. Now I've got data coming in from the Netherlands and global data. And now I have data coming in from the other side of the pond. You can tailor the subpath to return data like this. And this is showing all of the countries that I have products in, the total quantity and the total value, grouped by just the country this time. I can show cities with the most product, and I can also create helper functions to help me navigate this LTREE structure. For example, if I create a function called getProductLocationSummary, it takes the product name and the LTREE that I want to show data for, and it will return a table showing grouped information for products. For example, how much Kenyan AA do I have in this country or this continent or in the world? When I ran a software engineering team in retail, this kind of query and data would have been really helpful for me. Now I can get a product summary showing my global stock of Kenyan AA. I have 192 kilograms. The average price across my 8 cities is 46.88, and my total value is 9,033. If I just care about a specific country, let's do the UK. I have 60 kilograms, my average price is 39.67, and my total value is 2,385 across 3 cities, Edinburgh, Liverpool, and London. A benefit of being built from the ground up is that when our customers ask for new functionality in CockroachDB, we can add it very quickly into our roadmap. And that's exactly what happened with LTREE. Now, this was a whirlwind and by no means exhaustive introduction to LTREEs in CockroachDB, but we do have some fabulous documentation on the subject. So if you're looking to unlock complex hierarchical workloads for yourself in CockroachDB, head over to the docs and see how LTREE can be useful for you.